Go through the process of doing correlation and regression on Excel. I'm also going to make this more of a calculator style version, just like you have last time for your p-values. So if you set it up correctly, you can have it, you input new data, and then it's still going to update. So I have some imaginary data here, some kind of made-up data with x and y values. So we can see x values in the kind of 200 range and smaller y values. I'm also going to show you an interesting feature of Excel that lets you highlight cells based on ranges or values. So we can use that to get a quick idea of if our correlation that we're going to find is significant. So just to find the correlation value, so R, the measure of how well these two fit together for a line, Excel's function for that is kind of correl for correlation. And what we can do is select the entire column so that even if we give it new data, it will update. So just select all of column A, or you can type A:A. And so we'll repeat that for the y values. So B to B. We can click on the column. So we can see the correlation between these two data here is pretty strong at around 0.92. Negative, so as the x values increase, the y values actually tend to decrease. Okay, so if we're going to calculate our test statistic and p-value to determine if these are significantly correlated, we'll need to know how many values there are here. So we can do count, and count of the amount of values in either column X or Y. We should have an equal amount of them. So count from A to A or B to B. There are 12 values here. You can count automatically ignores text. So if we're going to continue doing the hypothesis test here, just a reminder, the null hypothesis is that the population correlation, so that symbol is rho, is 0, and the alternative is then that the correlation is not 0. So this is going to show that the correlation is significant. So we're going to calculate this as a t-test statistic, and so the formula for the test statistic is here. So we have everything we need. We just need R and N for that. So we're going to take our R value and divide. We have a lot of stuff in the denominators, so we have to be careful here. Square root, and then this needs to be in a set of parentheses for this fraction here. So 1 minus R squared, all of that divided by N minus 2. So N minus 2. So our test statistic is -7, so that's very strong for a t-value, usually above 2 or 3. So this is going to be statistically significant. Negative because we had a negative correlation. So we can get both a positive and negative correlation here. So alpha, you can type in whatever it might be for a particular problem. Let's say this one was 5%. And so let's calculate a p-value. So to make this a calculator type version where we don't have to go and adjust it every time, so t.dist, and this is a two-tailed test, so .2t. Our value is our test statistic here, but .2t wants positive test statistics, so we're going to take the absolute value, that's ABS, of whatever our test statistic is, just in case our test statistic is negative, like it is in this case. Our degrees of freedom, you can actually see somewhat how it is in the formula, is n minus 2, so similar reasoning there. Roughly, we lose 1 degree of freedom from both the x and the y values. So our count minus 2. So this is written in scientific notation automatically. If you do want to change that, in Home tab, in the number region here, we can change it to a number and maybe round to 4 or 5 decimal places is common. So this is a 0 rounded to 4 decimal places, 0.0002 rounded to 5. So this will let us input new values and everything will automatically update here. One quick thing we can do is if our p-value is less than alpha, we would reject, which would tell us that there is that the variables are correlated. And we can do that by a quick color coding. So in conditional formatting, we're going to say that if we're going to highlight the cells, and then we're going to compare this one to alpha. So we'll start with less than. So if the cell that we're in here is less than alpha, so select that one. Let's color code it green. Green means we reject. Normally we want to reject the null hypothesis. And now we'll see it's green. So this is green because it's less than alpha and it's rejecting. We might also color code it red to show that it did not reject. We failed to reject the null hypothesis. And you still stay selected on the same cell. And if it was greater than, we can change it to greater than or equal to just to be safe. It's very unlikely we get these to be equal to though. We're comparing it to this cell here. So if our p-value is greater than alpha, we fail to reject, and we'll leave that as red. Right? It'll only choose the color coding that makes sense. We can experiment with it right now by putting a value that is definitely less than that. So right now, 0.00002 is greater than this alpha with an extensive amount of zeros there. And we can see it changed color coding to red. And you have quite a bit of options for conditional formatting. We have scaling options also, and we can even do stuff with text. Let's put that back at a more normal alpha value. So we have this set up. First, we check if values are correlated, and if they are significantly correlated, so if your p-value here is small, then you can continue to apply the regression. It is not appropriate to do regression unless you have checked if the correlation is high enough, and the p-value can tell you that. So to find the slope of the regression line, so m from a mx plus b format, the formula is just called slope. So slope finds the slope of the regression line. It wants the y values first, and again we're going to select all of the column, so b to b, and a colon a for all of a. So this will let us go and input new data quickly. If you did want to do it just for a small amount of data, you can select just that data. So the slope between there, so the slope is slightly negative here, 0.01. We can see that the values are changing from larger x values to smaller y values. So we see a very small slope there. And so the standard interpretation is if we were to go up 1 in x, y goes down on average by 0.01. And these should always agree. Your correlation and your slope should have the same sign. Y-intercept, we can also get just directly the Y-intercept formula. So that is called intercept. And again, select the y values first, select the whole column so that we can change our values as needed. And it wants the x values next. So our y-intercept is about 3.8. We can round these to more reasonable decimal places if we wanted. Whatever our problem needs us to do there. Test statistics are often rounded to much less decimal places, as are correlation values. We can also make a quick regression calculator so that we can input a value. So if we need to calculate a y value from an x value, which is one of the reasons why we might make our regression line, so we can leave this spot here open. Maybe let's highlight that. So So we'll input a value here, and to calculate it, it's going to be the slope times whatever value is here plus the y-intercept. So if we wanted to calculate for a value of, let's say, something in our x range that seems reasonable is maybe 160, we'd expect a value of 1.99, 2.0 if we round to a few dozen places. And we can see that makes sense. Values in the 160 range look like they might be around 2. So that seems reasonable here. Now I can change this as needed if I need to predict any values. And write this one as x goes up, y is actually going down. So 180 there agrees very much. This would have a very small residual compared to that. Let's see if we calculate at 190. We'd have a 1.67. We have an actual value of 190 here, just a little bit less. So we have a few other ways we could have done this. One thing we could do is visualize all of this. So I'm going to select a little bit extra of the data. So maybe I'll scroll down 50 or 60 columns. We probably don't have data more than that. And then I'm going to insert a chart. The recommended chart probably guesses right. We're going to insert a scatter plot. And we can see that the values are highlighted all the way down here. So if I need to input a new value, so let's say I had a value for 160 for x, 1.95 for y, everything has updated appropriately, and the value actually updates on the graph. Let's get one that's maybe easier to see. So I'm going to give a value a little bit further away than the rest of these. So let's say 220 for x, and maybe that would have been 1.6 for y. You can see the new value show up there. So we could have found some of this other information a little differently. So if you select your chart, and then in chart design, select trend line, and then linear. This may be in a slightly different place if you're on a different version. You might see it in the chart menu itself or near the chart itself. So I'm going to add chart element, trend line, and if I click more trend line options, so the trend line is already here, but if I select more trend line options, I can display the equation on the chart and the value for r squared. So r squared is a common value we want to look at. We don't have the option, unfortunately, of showing r. If we did need to quickly get r, we could take the square root of that. This is literally r squared. And so that's a nice clean way to get a lot of the information. It doesn't give us a p-value, so we don't know if it's significant. But it is important to verify visually that our values look good. We want to make sure that there's no obvious pattern here, that our values aren't curved, and we can't do that without looking visually at it. One last way that we can get a lot of this information all at once and some extra information is to use the Data Analysis Toolpak. So if you already have that installed, you'll find it in Data, and then Data Analysis, and then you're going to select Regression. So you're going to select the y values first, and then the x values next. If you selected the labels, tell it there are labels. You might not need any confidence intervals, so you can deselect that. And I like to put it on the same sheet I'm working with, so I'll put my output range maybe here. I have a lot of options I can select with that. We'll not select any of those now, but if we wanted to look at the residuals or any of the actual plots themselves, we could see that here. This has all of the same values we did. So our correlation number is labeled as multiple R. Multiple R because if we did a multiple regression and we had multiple types of x values is where this wording comes from here. Adjusted is a little bit more advanced technique that calculates or takes into account how many sample values this is for. So we can see that this almost agrees, but multiple R will only output a positive value. So if it's negative, we do have to be careful there. This is another place to get the p-values that we were looking at. So there's two places to look to find the equivalent p-values. So we were looking if the slope, another way to do instead of correlation is to test instead the slope itself. So we have two sets of values here, and the one that is labeled on the bottom will be the p-value that we had found earlier. So this is the same as 0.0002. Is also in the ANOVA region. The only downside to using the data analysis Toolpak here is that this one doesn't change if we input new numbers, so we would have to reselect this for new data, but we get a few more pieces of information right away. We also get some confidence intervals for the actual values of the Y-intercept and the slope, so we might use those to figure out what is the range for the Y-intercept and the slope. So those are the three different ways we can get the equation for the regression line. We can do it directly from some simple Excel formulas. We can do it visually and get it outputted at the same time. This will also help remember the ordering of the Y-intercept and the slope. I think I forgot to say this. The values for the Y-intercept on the slope are located here. So the first value is the intercept, labeled intercept, and then will be the slope beneath that. So for the data posted in Canvas, just go ahead and repeat all of this. You can use this for any future homework problems in correlation and regression. Everything towards the left here will automatically update with new values, but the Toolpak method here would need to be redone if you give it new values. All right, thank you.